Hello guys, just a bit of a catch up at the end of the year. Some news, we've got a new pump we're shipping at the moment. You can see it's slightly bigger. Here it is. This is the one we've been using. The mechanism is identical, it's the same pump, the same manufacturer. The casing is different. And a key thing is the nozzle here, which is rubber, goes on the end there. And in terms of the sound output, the mechanical sound that comes from the pump, it does help that a tiny bit. And we're hoping the casing does make a bit of a difference. But in every other respect, the flow rate and the sound and everything, it's officially identical. But you know, we're doing that. Some of it's because of supply, some of it is to see if we can reduce the sound further. And taking the vibrations out with this rubber piece does seem to help that, but it's tiny. But we'll see how that goes. In terms of the kit, that's it. We're not changing anything. In terms of what we've been doing, what our customers have been doing, you've probably seen on Trustpilot that we're getting some really lovely reviews about how effective the thing is, and we're getting detailed reviews, which is key to us learning. And you'll probably have seen we've also been to see customers. What it's actually achieving is to spread the heat very much more effectively. And we have been doing engineering work, and a bit of a Christmas presents we got is to have a complete model of a room being heated by a stove without a Recoheat and compared to a stove with a Recoheat. And what it shows is that without the Recoheat, you're getting very hot area, goes right to the ceiling, obviously, and that area is nice and hot. And after you've had the stove on in this simulated room, which is 4 meters by 3 meters by 2.5 meters, so quite small, but after an hour, the bulk average temperature in the room is 23 degrees. So it's going up from 5 degrees. But that bulk average temperature is all hot. On the animation, you see it's red all around the stove, up the flue, and then it's orange along the floor. If you compare that with the Recoheat, the bulk average temperature after an hour is 26 degrees. So not very much difference. But if you look at what that average is, the evenness of the heat is extraordinary in comparison. And beautifully, we can actually see what's happening. The simulation is done at 10-second intervals across something like 1.6 million points within the room. And what's happening is that the jet of air is coming out here. After 10 minutes, the temperature of the room has risen to 21 degrees with the Recoheat on, which takes an hour without the Recoheat. So you've got a comparison in the timing of the heat. But what's happening is that the jet's coming out, it's drawing the radiant heat into the jet. It's called entrainment. It's dragging that heat out into the jet, but it's then also drawing cold air into the jet. And as they mingle, the jet's coming out here and it starts to oscillate. And you can see this oscillating effect in the room, in the airflows in the room, and it's doing this. And it's that more than the pressure. The specific effect is an oscillation. So you see the waves of air turning, and they're turning around the floor and up to the ceiling. So the evenness of the heat is extraordinary after even such a short time. So we're putting more heat in, obviously, from the heat recovery, but it's the stirring action that is the massive thing. And so, I mean, what's wonderful about it is that, for example, Jamie down in Cornwall sent us his data, and you probably see on Trustpilot, he said it brings his room to 27 degrees. Well, the modelling set the temperature after an hour at 26.1 degrees, so almost exactly the same. I spoke to somebody else this week who, in the -7 degrees of that we were suffering last week in the temperatures, his room with the Recoheat was heating to 21 degrees in 15 minutes. In a very badly insulated house, and he was delighted with that because, he said it'd have needed a 2 kilowatt minimum big fan heater to have achieved anything like that. And at 4:30 in the morning, when he gets up and lights his stove, he actually had somewhere warm to drink his coffee. So he said in this very cold, poorly insulated home that the room was 21 degrees whilst the stove was cool enough to put his hand on, which is exactly the same as the simulation. They're saying it's 10 minutes to 21 degrees. There's the various things that are exciting about that. One is that we can understand properly for the first time what is happening and how it's happening. Another is that the simulation and the model that we've got, we can now test engineering developments on. So we can run simulations on anything that we want to do. We've been trying to do all sorts of things, from new pump to nozzles to building a system for boats so that we can go from flues with 4 inches into some kind of a bell shape around the 5-inch coil. We need minimum 5 inches around the coil to get the airflow. We'd like to be able to make a unit that goes from 4 inches into 5 inches and then back down into 4 inches. But we don't know, and haven't risked creating a cold patch in that area so that you then damage the circulation of the flue. We can model all of that stuff now. And just as it was the modelling early on that told us we couldn't put the coil into the horizontal because of the way the vortices work and the way that the coil keeps clean, we can do this without having to rely just on the empirical, which is all fantastic. Up until now, until we started having this kind of engineering stuff coming through, it was all empirical, and we had some good, clever people, good engineers telling us it was impossible. Mike on the first video was, all of his engineering observations are absolutely accurate. The one thing that wasn't was that he said it didn't work. And we've always been stuck with the problem that it works. And it's really difficult to understand it. The physics is complex, but only in its effect. What we're doing is simple. But to actually be in a position to understand it is fantastic. And it will be transformative for us. So we've got lovely customers telling us how it's working. What seems to be the sort of rule of thumb is that the system works with convection. We've got one chap who has a house. He's got a big room, 24 foot. He's got a very cold corridor at the end of it. And we put the Recoheat in thinking that it would go through into the cold, particularly because I thought it was the pressure difference that was driving the airflow. It hits his really cold corridor, which is it's paving slabs onto sand. It's grade 2. He can't do anything with that, and the heat's just hitting it and dying. And you stand one side of the door and it's 26 degrees. You stand the other side of the door, it's still really, really cold. So the convection flow is going backwards, and the Recoheat, the standard one, isn't working. Maybe you could put a massive fan on it, whatever, but he's been putting fans in the room and doing all sorts of things. So it hasn't worked with that. But it's the only one actually where it hasn't worked. You can see generally that if you build up the heat in the room, you get that hot, you open the door, and that bulk warmth then creates a draft, and that's the key thing. Sometimes you'll find that if you just have the doors open and let the room heat up slowly, it doesn't create the draft. You often need to build the heat up and release it so that you create that through draft. And that's very similar to the chimneys. If you saw the video with Tom, he's got a chimney flue coming off the back. He's got a register plate, and the flue goes through the register plate and stops, which was standard. It's what his Rayburn was designed to do. Works absolutely fine. But for the Recoheat, it reduces the draft going tight around that, because the air will come up through the flue and then it will dissipate, and so it's not such a strong, clear direction full draft. And he preheats the Recoheat. He preheats the coil. So rather than just switching it on and that instantly starting to cool the flue gases, which it does to about 5%. But where that's a very delicate balance, he gets around that by letting that heat up first. And because it's the same temperature as the steel in the flue, so it's then it is completely identical to the rest of the flue. And once that's hot, he then switches it on, and that allows he's got the draft going, and that the draw then means that you don't get any effect. And it's all about windows. It's all about operating windows where you're working, and flues are like that. If you get a cold plug in your flue, you get smoke coming out, and that's a lot of people will have got that last year. And on the forums, everyone's why is my stove smoking? And it's because your flue isn't pre-warmed enough. And so to get around that, you might be opening your stove up before you light it, putting candles in, putting hair dryers in to warm the flue to create a draft going up. And so if there is a difference to be made there, preheating the coil can do that. Another time that can happen, we're selling quite a few in Ireland, and in Ireland in the summer you don't get draft, because the difference in the pressure between inside and outside is so tiny. And so a unit and a stove that functions absolutely fine all through the winter, come to June when you light it, you might get problems with the draft, but that won't be because of the Recoheat. It'll be because there's no pressure. The chap who runs Exodraft, which is an electric fan that you put on the top of the flue, works fantastically. But he was saying that people didn't realise that the difference in pressure between November and March is about 14 pascals. So you've got in November, when you've got beautifully functioning stove, you get to March and you may not have the draft to do it. So we're working within those constraints. We are trying to ensure that the operating window of the Recoheat is as identical as possible to the rest of your flue. And so that the modelling suggests we're taking 5% of the heat out, and of the bulk average temperature. And that heat loss, or that heat exchange, is very, very local to the coils. So it's taking heat out, and you can see it cooling it out to 10 mil from the sides of the sides of the coil, but it's still the same temperature. The flue gases are still the same temperature up the sides of the flue, and that's again, that's partly why we're not going any narrower than 5-inch diameter, because we need that. So it's really interesting. It really works. Other things we've found out, we've changed the instruction manuals. This stuff, that's great, but it can't be, touching the stove. And even here, you've got clearance and it cools. But if you actually closer, I've put within 50 mil. If you're closer than 50 mil, swap it for copper, because the copper, gets as hot as you want and goes up and down. But this stuff is dried out and damaged, and will totally be destroyed if it's actually in contact with the stove. But just to make sure that you're not getting any damage to it, or it's not going to be drying out and getting destroyed, then I'm saying 50 mil. Get 50 mil clearance, and if you haven't got 50 mil clearance at the back, it's obviously it's mostly at the back of your stove, then just use copper. and the 10mm copper, my brother fitted it. It looks very Heath Robinson, but it's pretty. You can paint it, and it means there's no worries there. I mean, this one's been on for a couple of years, and the amazing thing with it, even if it does dry in an area, so where we've seen it and it was actually touching, and it's desiccated completely, very locally, a few mil away, it's completely clean and completely rubbery, and it hasn't lost any of its properties. So it is, it's a really good material, but it's rated to 250. And as I say, when Bizria tested it, and when it was running, it didn't get above 42 degrees. So it's being cooled all the time. So in normal circumstances, it's absolutely fine. But you do need to follow the rules with it. Otherwise it does get destroyed. And apart from that, we have now got, we've now, this year's been, something of a breakthrough. Since September, we've been selling the units steadily and getting, so we've been learning a lot from our customers. And next year, obviously that will change. Again, we should step up quite a lot with the new engineering developments and the knowledge of what we're doing there. And that's what we'll be doing. So, it's all down to you lot. It's all down to the customers talking to us when we've hit problems, actually, still talking to us and, allowing us to come over to see what they're doing, to learn from them. And, we're really grateful. It is a fantastic product. It really does work. We're a tiny little company, developing this after, of good experience. Kevin invented this in 2014, and the changes that we've made have not affected. We haven't touched the coil. The coil's absolutely key. The empirical engineering work that he did on it was impeccable, and the one thing I'm not changing, we're not looking at changing at all, is this. It works really, really well. And so whatever we do, that's the key to it. And so we've learnt a lot. We're sticking with what we know, taking no risks, developing it. And it's all thanks to you that it's going in that direction. Thank you very much, and have a lovely Christmas.